Dear student, I am going to talk about voltage today. In my last video, I had talked about current and today I am going to talk about voltage and volt. I hope you will enjoy my company and you will learn something today with me. Electrical current is nothing but flow of charges from one end of the cell to the another end of the cell. When you are pushing a car, you are spending your strength. In terms of science, we call it as a work has to be done in pushing the car from one position to another position. Similarly, a cell has to perform the work in pushing the charges from one place to another place. Every electric cell has two ends. One side is more potential called high potential terminal and the other end of the cell is called low potential terminal. Thus, every electric cell has two ends, high potential side and low potential side. Electrons are negatively charged particles. Therefore, in DC supply, electrons are attracted by the positive terminal of the cell. That is, in DC supply, electrons flow from negative terminal to positive terminal. Electrons are negatively charged particles. Therefore, flow of electron nothing but flow of charges. Electrons start suppose from point P. They travel through external circuit and come to the point Q. Again they come back to the point P. The flow of charges in a circuit forms a closed path. That is, the charges start from a point P and flow through external circuit and come back to the point P. Thus, flow of charges forms a closed path. The electrical cell pushes the electrons from one point to another point. This pressure, which pushes the electrons round the closed path, is called voltage. The another word for voltage is electromotive force. We can define electromotive force as follows. The energy supplied by a cell to circulate a unit charge one time round the complete circuit is called electromotive force. In short, we call it EMF of the source. EMF is nothing but the potential difference produced across positive and negative terminals in an electrochemical cell. Electromotive force and potential difference more or less are the similar terms. The unit of potential difference or electromotive force is volt. The EMF of a given source is equals to 1 volt if it supplies energy of 1 joule to circulate a charge of 1 coulomb round the closed circuit. If W be the work done when a charge of q coulombs moves from one point to another point, then the potential difference between the 2 points is given by V equals to W divided by Q. That is, voltage equals to work done per coulomb of charge. The potential difference between two ends of a cell is equals to 1 volt if 1 joule of work is done when a charge of 1 coulomb travels from one point to another point in a closed circuit.